Let's take a look at a rice table problem. We're going to look at the problem that goes R for reaction is UO2, gaseous, reacting with 4 HFs that are gaseous, that will go into equilibrium with UF4 gaseous and water vapor. All right, so I can see that everything is gaseous, so whether whether we are dealing with KC or KP, everything will be viable to go into the reaction. If you look at the problem, though, you'll see that it's not giving you concentrations or pressures. Now, it's giving you moles, all right? So I know that moles over liters equals a concentration, right? So that's what we will do. So it's going to give us a whole bunch of mole counts, all right, for each of the substances. And then it tells me that the entire reaction is taking place in a 5-liter container, all right? So in other words, we'll have to divide the amounts by 5. All right, so if I do that, I'm going to end up with my initial concentrations of 1.2 molar and 2.46 molar, again by dividing the given moles by 5. Of course, the products always start with initial concentrations of 0 because the reaction is not started yet. I use minuses for the reactants because they will go down. I use pluses for the products because they will go up. I bring down the coefficients, which are only those two, and then give an X to everything. E is I plus C. So let's combine, and here we're going to get 1.2 minus x. Here we're going to get 2.46 minus 4x. Here we just have x, and here we've got 2x. Now remember, this is always the point where the problem will give us a bit of bonus info. And in this case, it says that at equilibrium, there is 1 mole of water. At equilibrium, which means after the E is completely done, there's going to be 1 mole of water. Now, I can't just use that 1 mole because that 1 mole of water is still going to be existing in the 5 liters. All right, so to get to the final equilibrium concentration, which is what these values are telling us, we'll have to divide 1 by 5. And if we do that, it's 0.2. So I know that this right here, this 2x, which is the water, needs to equal a concentration of 0.2. And if I take that into account, then I can figure out x. All right? So if 2x equals 0.2, then I can figure out that x must equal 0.1. All right, and now I can find the concentration of everything. So for the water, we already found that the water is 0.2, right? It basically told us that. All right, the UF4 is just X for his equilibrium concentration, so he's going to be 0.1. All right, now here's where we have to do a little bit of math. In order to find HF's concentration, it's 2.46 minus 4X. Which means 2.46 minus 4 times 0.1. So you'll need to run that, and you'll get 2.06 if you solve that equation. And then finally, 1.2 minus 0.1 is 1.1. So now I've got my concentrations for each individual component of the equilibrium. So the unsubstituted equation, of course. All right, now we're using concentration, so it's going to give me Kc. The problem here is that we're looking for Kp if you read the problem, so that's going to be an issue at the end. But from concentrations, C, we can only find Kc. So it looks like it's going to be UF4 and H2O squared on top over UO2 and HF to the fourth on the bottom. All right, so now we'll substitute that, and it'll be Kc equals, and now I'll have all these values show up. All right, so the UF4 is 0.1. All right, and then the H2O is 0.2. The UO2 is 1.1. And the HF is 2.06. All right, so there's a lot going on here. We could simplify this piece by piece. All right, so I'm going to go 0.1 times 0.2 squared, and I can get a top number of 0.004. And then on the bottom, it says I need to go 1.1 times 2.06 to the fourth. All right, and that's going to give me 20. All right, so if I run that, we will get a Kc value of 2e negative 4. Now, if it wanted Kc, that would be good, but it wants Kp. And remember, we can only get Kp from pressures, and it did not give us pressures. That's why there's the disconnect there. But we know that we do have this equation for converting between Kc and Kp. So we can plug and chug into there. Hang on a second. Looks like my video froze.